So red tide is a very naturally occurring organism along the west coast of Florida. It depends on a combination of both the biology of the organism itself and the physics of the ocean circulation. So the ocean circulation sets up conditions in the ocean that are either conducive to or not conducive to the formation of a bloom. And the ocean circulation then carries the bloom to the beach where it manifests and where we actually experience it as humans. For the last couple of years, we've had fairly strong red tides. And what we're seeing right now is a combination of the residual from last year's bloom, which has lingered, and aspects of a new bloom that are first beginning to arrive at the beach. So we look at the ocean circulation. We're not biologists, so we're actually interested in the ocean circulation contribution to a red tide bloom. And we found by looking at a combination of data from satellite and coexisting red tide information, we found that for 20 out of the past 25 years in which we have concurrent data, we can actually predict the existence or non-existence of a major bloom simply on the basis of the ocean circulation. That's how we do our seasonal prediction. To do the short-term prediction, we collaborate with scientists next door at the Florida Wildlife Commission, who actually go out and measure red tide when it's been observed. They pass those measurements on to us. We use those measurements to initialize a circulation model and then project over the next 3.5 days where those red tide cells may go, driven by the ocean circulation. So it's a combination of looking at larger scale circulation to see whether or not the West Florida shelf is conducive or not to a major bloom, and then once we have a bloom, use actual observations to trace where that bloom may be heading. So our understanding is that red tide initiates offshore, not near the shoreline. It actually initiates maybe 50 miles offshore. And it comes in, not at the surface, but along the bottom. Totally lacking are regular observations offshore in the formative region so that we can use those observations to initialize models. What you see along the beach has two contributions to it. The first is what may be moving north-south along the beach, but the other is what may be coming in from offshore along the bottom. When there's a bloom, we do get observations along the beach from the FWC, but we do not get observations in what we believe to be the formative region offshore. So that's what's missing. That's what's required to make better predictions. We have the tools to do this. We have robotic gliders that we can send out on a regular basis, sample the entire water column for various properties. Normally when we do this and there's a red tide bloom, we see very high concentrations of chlorophyll near the bottom, not near the surface. You only see it near the surface in a satellite image once it's already come to the shore. You don't see it in a satellite image when it's forming up offshore. So we need to support a fleet of these gliders. If we send a glider out and we see what may be indications of a red tide, then we want to have resources to actually send a ship out, sample the water, look at the organism under a microscope and find out exactly what that chlorophyll patch is associated with. And so that's the main missing link in prediction. Red tide prediction is kind of like weather prediction. Weather prediction is lousy unless we have observations to initialize models with. Red tide predictions are no different. We've got to have observations to initialize the models with in order to improve upon our predictions.
What would that shipboard sampling look like? Small boats, large boats,
Well, it depends how far offshore you have to go. If you have to go far offshore, you need a larger boat. But if we find red tide, within 10, 20, 30 miles of the shoreline, we could send a smaller boat out to collect water. That would be a much more cost-effective way of doing it. But until we start having regular sampling with gliders, which are cheaper, we don't know where to even go with a boat to make the sample. So, we had this Deepwater Horizon oil spill back in 2010. This is now 2018. There have been a lot of resources made available on the basis of the penalties associated with the Deepwater Horizon spill. It was the hope of many of us in the oceanographic community that some of those monies would be used for long-term observations of the coastal ocean to get a better understanding of how the coastal ocean actually works, to put in place more observations, and also to improve upon the models available, not just for red tide, but for tracking oil in the event that there might be another spill. Well, very little of that has actually happened. It's been a lot of money spent, but spent on projects that are politically expedient. We need more money spent on actually making ocean observations to figure out how the ocean works and to improve upon the models that we have to predict the consequences of either man-made changes to the ocean or naturally occurring phenomena.